This video is number 2 in a two-part series for solving just enough right triangle trigonometry for projectiles launched at an angle problems. If you have a right triangle with known velocity components and don't know the angle it's launched at or the speed it's launched at, you can solve for that unknown resultant velocity and angle. Here's how. Okay, unknown resultant velocity. That is a matter of the Pythagorean theorem. This is a right triangle, so I know that a squared plus b squared equals c squared. And pick any two side legs as a's and b's, this is c. Solving this equation for c, c is the square root of a squared plus b squared, and that's what you see drawn on the screen here as the hypotenuse of the triangle, right? That is the Pythagorean theorem. To get the angle, this is new information for many of us. We're going to use the inverse of those right triangle trig ratios that we learned in the last part. Just as a reminder, in the last part, we learned that sine, cosine, and tangent, not used terribly often here, are ratios of any two side lengths of this right triangle. Given an angle, that function will output a ratio of two side lengths. The inverse function says, given the ratio of two side lengths, what is the angle? And here's how it works. This one's called the inverse tangent function. Okay, so just remember, the tangent of an angle is the opposite side length over the adjacent side length. The inverse function takes in that ratio of two side lengths and spits out an angle. Likewise, there are inverse trig ratios for inverse sine and inverse cosine, both of which will output the angle. So just depending on which two sides of the triangle you have, you will use one of those three functions. Next, let's look at an example that uses these inverse functions in order to find the angle and the resultant velocity. This is example 2 on the next page. I have here an object that I'm told is traveling horizontally at 10 meters per second and vertically at 5. What is the resultant velocity and the angle at which this thing was launched? Again, first we sketch the right triangle. I've already walked you through that. Now we're going to solve for the resultant velocity. This uses the Pythagorean theorem. The resultant, or hypotenuse of this triangle, is the square root of 5 squared plus 10 squared. So square root of 125. This is not a perfect square, so I'm going to calculate this. That is about 11.18 meters per second. Solve for the angle of that velocity. Here we go. We're going to use that inverse trig ratio. I'm going to find the inverse tangent of the y component over the x component. On your calculator, you'll need to use the second function to get at inverse tangent. The angle that I get is about 26 degrees. Using inverse trig functions in order to find an unknown angle and an unknown resultant. Thank you.